Good day everyone. This presentation is for the ECNG 3020 course, which is Electromagnetic Field Theory, and this presentation is on behalf of Group 22, and the theme of our topic is RF safety. The reason why we need to research on RF safety is because persons need to be aware of the potential effects of RF exposure. For example, studies done by the Bioinitiative report have observed that RF emissions can cause diseases in humans such as cancer, immune dysfunctionality, and even neurological disease. Hence, the aim of this study is to investigate whether a continuous monitoring sensor node communicating with a mobile handset at the waist would exceed the safe levels for RF exposure established by the IEEE 802.15.6. For the concept modeling of the system, we had to use the galvanic coupled IBC method, and IBC basically stands for intra-body communication. We decided to use a 2D model instead of a 3D model, and this was based on a previous study that was done by a Center for Wireless Communication in the University of Oulu in Finland. In order to design the body, a model for the body, we had to choose 4 different layers of body tissue to represent this. The 4 layers were the skin, the fat, the muscle, and the bone. The antenna, which was the emitter, was located on the surface of the skin, while the sensor node was located in the muscle. In order to model this design in COMSOL, we had to first choose the dimensions for the 4 tissue layers previously mentioned. The materials used for the tissue were available in the COMSOL version 4.4, and each of the body tissue materials selected had their own electric and magnetic properties already built in. For the physics of the study, we chose the frequency domain, which was appropriate for our field of study. In order to set up the field, we chose the RF module and also had to set up the boundary locations. Also, in choosing the dimensions, we also had to create a union to ensure that the RF would propagate properly throughout all the skin layers and through their boundaries without passing through any unknown matter. This picture here shows the results that we obtained from the simulation in COMSOL. If we look at it for the simulation, we had to choose it. We chose a 21 MHz signal, which was in accordance with the IEEE 802.15.6 standard. And this section could have been chosen as a source because the system is assumed to work on a half duplex communication channel, which meant that only one transmitter would be transmitting at any point in time. An electric field resembling that which the phone would generate was used to obtain a simulation in a form easily relatable to the IEEE C95.1 standard. The results were in the form of electric field strength. A field strength of 100 volts per meter was used for the X and Y components, while the Z component was 0 volts per meter. From the simulation, the electric field strength was found to vary from 190 to approximately 4.3 volts per meter. Sorry, 100 to 4.3 volts per meter. The World Health Organization Bioinitiative report suggested that the electric field strength for outdoor communication should not exceed 0.614 volts per meter, and also the FCC limits for maximum permissible exposure at 21 MHz was 87.7 microvolts per meter. So clearly, from the results that were obtained, it was realized that our study exceeded the set threshold values for safe RF exposure at a frequency of 21 MHz. Therefore, what can be done is that the safe RF limits could be revised so that humans and their health could be protected.